Welcome back to another episode on Build It, Wheel It, Explore It. So, in a nutshell, the past Memorial Day weekend at Silver Lake Sand Dunes, I had some the last morning of the trip, the truck didn't start up very well. It was smoking, hesitation, and whatever. Anyway, I found that there was plugs number 2 and 3. The wires had a split each boot, which was crazy because before that trip, I put a brand new set of live wires, 10mm plug wires on that thing. So those got hot. More than likely were arcing. Truck was smoking really bad, super rich fuel. You could feel it, smell it. It was terrible. Got home, did some stuff to it, couldn't really figure anything out. I cleaned the MAF sensor, I put a new fuel filter in. Fuel filter did show some weird, almost like a water in the gas, so I dropped the tank, cleaned out the tank, put a brand new high pressure fuel pump in it, another brand new fuel filter. No change. But the smoking stopped. I put new plug wires on it. So whatever was causing it to run super rich and smoke, that part was solved. But then anytime I touched the gas to give it any gas, there was hesitation in my air fuel gauge, which is lean. So Brian Rasey had another computer laying around, so I swapped computers, and I ended up getting the opposite effect. Instead of running super lean, it was then running super rich. But then I could rev it like normal, you know. So it's like one extreme to the other with two different computers. I put a new TPS sensor on it. Everything is set up how it's supposed to be. But the problem is still there. So I got an update coming. Yes, I haven't vacuumed out the sand yet. So, stock computer location. Mustang computer is out. Gone. I'm going to be joining the standalone ECU club. Brian Rasey, Brad Kumler, John Parks have all been running Microsquirt, and they seem to really love it with no issues. So, now that I'm having issues with this truck, I'm going Microsquirt. So I got everything laid out here, and I'm going to start prepping the truck and getting this installed. It's really pretty basic. It's pretty much plug and play. You get the main harness, which goes to the factory computer harness in the truck, the 60 pin, and then the Microsquirt computer, which is really small in comparison to a factory computer. Look at the size difference. So like I said, this goes to the factory 60 plug pin, then this goes to the Microsquirt, and then you have a round pin connector, which is your programming tuning port for a laptop or tablet or Raspberry Pi device. You got 3 wires here. The yellow one's optional. That's to control an electric fan via the Microsquirt system. And then the green and yellow wire is a tack hookup. My tack's already hooked up and set, so I don't need to worry about that one. And then the last one is the pink wire. This is what goes to your air fuel wideband gauge. So my wideband gauge is right here. There's a white wire that supplies the output, 0 to 5 volts. So the pink wire will tap into that white wire. Just has a 3-foot run, no big deal. So that sums up that part of the deal. And then the factory Mustang setup runs a BAP sensor, barometric air pressure. That gets swapped out with a MAP sensor. So they supply that, a WeatherTech plug, pigtail with 3 wires, and then depending on what your wire harness you have, the corresponding wire colors to match the pigtail. And then you just supply a vacuum hose pickup from the map sensor. And that completes the install of Microsquirt as far as hooking it up. So let me get started. So one advantage of the Microsquirt already is you eliminate the map sensor. I guess you can run it with it, but with my situation going on here, I'm still not sure if it is actually one of the computers. I mean, how likely is it to have 2 computers both acting up in different ways? This is the only other thing that I didn't have any other extra things to swap out with. I don't have another 24-pound injector calibrated map sensor laying around to test and see. So there's a chance that this actually is what's causing some issues too. So this is going bye-bye. My BAP sensor is mounted right here, so I'm just going to unbolt that. I believe there's enough harness to actually bring it over here. And then I'll figure out what wire harness I have color-wise and match up the new map sensor. Remember, the harness on this is, this has a Ron Francis aftermarket brand new harness on it. So I gotta make sure I gotta see what color code the Ron Francis harness uses, if it matches one of the 2 ranges of the Mustang harness. So whether it's going to match an 86 to 90, or if it's going to match a 91 to 93 color code. But we'll figure that out here in a minute. Alright, so my first step is I already have an AEM air fuel gauge in the truck. So there's 2 harnesses on the back, a 4-pin and a 6-pin. 6-pin goes back to the actual wideband O2 sensor, and then the 4-pin is what gets your power and stuff from power source. And the white wire is normally a pigtail, but since it's already all wrapped up behind the dash, I wasn't going to pull all that out just to get the pigtail, so I just spliced into it right here. Adding on a wire lead here, and then I will cut it to length over here for the PCM side, for the to connect the other side to the pink wire here. Alright, so the white wire's tied in. Everything's been twisted together, soldered, heat shrink tubing, gauge is back in place, plugged in, and then like I said, the white wire taps into the pink wire, which is also obviously wrapped together, soldered, heat shrink, and then I just wrapped the excess with some electrical tape and to keep this plug kind of fixed so it's not pulling on the wires. So the air fuel gauge wire is complete. The pigtail harness is bolted to the stock ECM 60-pin plug. The Microsquirt computer is clicked and plugged in, and the laptop serial connection is plugged in also. Now let me get the map installed. Alright, so I got ahead of myself here. I meant to take a video of the taking out the BAP sensor and swapping over to the new map sensor for the Microsquirt. It's not a big deal. Earlier in the video I explained the color codes and the harness. So there's plenty of harness on the Ron Francis. And so here's the BAP sensor that I took off with the color code. So the Ron Francis basically matched the 86 to 90 wire colors. So the 5-volt wire, orange white, is orange on the Ron Francis, and then the center output, light green black, is the green wire on the Ron Francis harness, and then the signal return black white is basically gray on the Ron Francis harness. So it kind of follows the 86 to 90 color code Ron Francis harness does anyway. So I just matched the colors with that, and you're good to go. So on the new map sensor, it's red, blue, and black. So the red went to orange, blue went to green, and then black went to the gray. On the Ron Francis harness, that is. Then I just added a vacuum tee, and then gave myself a little extra 1/4 inch vacuum hose. Still have to mount this yet. I'm gonna mount somewhere. I need some longer screws though. It's a little bit thicker unit. So everything's all set. And then a lot of people have issues with the actual serial to USB adapters. So I had originally bought, because I did look up their instructions, and basically they want you to have a serial to USB that has an FTDI chipset in the cable. So this serial to USB has that chipset, but then our other buddy Eric Doucette recommended going to these guys, DIY Autotune, and buying their serial to USB adapter. It's guaranteed to work. So it comes as a short, hard type unit, and it does come with USB extension pigtail harness too. So I chose to go with this brand because it's pretty much guaranteed, or is guaranteed, and they have full support. So I'm just going to return that one back to Amazon, even though that one probably would have worked. I don't even need to bother with it at this point. All right, so that pretty much shows all of the parts and components of the Microsquirt system, how it's installed. I mean, it's really a real basic install setup. You're basically only touching a minimum of 4 wires. The signal wire, 0 to 5 volt from the wideband gauge, and then the three wires in the pigtail for the BAP to map sensor. And then you got the optional tack hookup and electric fan. So I already have that Flexolite variable fan controller set up on this, so I'm just going to keep using that. And then all of my gauges are speed hut gauges, and obviously my tack's already set up. So if you already have an existing truck that has, or car, truck, whatever, that already has some stuff in place, you don't need to mess with it. But obviously if you're starting from scratch, then you would hook up, you know, whatever wires that you want to add to it. And then if you don't have an air fuel wideband set up yet, gauge, obviously that needs to be added. So huge shout out to Brian Rasey. He is the go-to guy here in Michigan with our group, especially, you know, our Team Ford that we have here in Michigan. Brian has microsquirted, I think he said, at least 4 or 5 different vehicles. And I think he said his first one was like 10 or 12 years ago. So he is pretty damn good at this system. And then obviously we're all kind of running very similar motors, which is very small difference between. So even though he worked the night before, he got up and spent a ton of time with me over the phone, messenger, text, walking me through every aspect of setting up the initial tune. So I'm going to show a video here of it starting up and running. I was a little bit unsure for a few minutes because it seemed to not set up as good as I thought it might initially. But then, like I said, once Brian was available, he started walking me through everything, and we got this thing idling good, everything's set up, everything's looking good on it for as far as the rough setup. So it's good enough for me to start it up today, get up to temp, and start doing auto tune, where you let the laptop run with the program, and the computer basically runs and calibrates while you're driving under all different circumstances, idling, slow speed, high speed, all the variables. So that's what I'll be doing here next. So I will show a startup video with the digital dashboard on the Tuner Studio software to show how it's running and where I'm at currently. Again, this is just the base tune with very rough adjustments. So I'm going to start the auto tune process here soon. Get as much driving time as I can today, and then I'm actually going down to Brian's house the following weekend, and he's going to fine tune it with me. So
started.
Alright, we're going to do some cold start and some street tuning on Dan's truck here. So, I'm Brian Rasey from Random Adventures. So, I'll show you here real quick. I'm going to zoom in here. We're in warm-up enrichment right now, so 13.5 AFRs. That's actually pretty lean, but it's warm. We got 120 degree coolant temp, 120 air temp under the hood, so we're going to go for a cruise, get it up to normal operating temp, and get it out of warm-up enrichment. Then we can start making changes to it and see what it's doing.
Rolling.
All right. So you've already been doing a substantial amount of auto tuning.
Yeah, I did probably a good 10 miles of street driving, and then probably almost an hour off-road with 4-low, loading up everything. Nothing crazy, but...
All right. So for now, we're just going to watch until it gets up to temp. Oh, okay, so warm-up enrichment just turned off. So it must be after it passes like 170 degrees. So now we can go ahead and you saw that little hesitation there. So I'm going to open up the VE table here.
The windows, too much noise.
So you can see on the 3D map here, you can see all the peaks and the valleys where it's rich and lean. So up here, that's kind of lean spot. Need to richen that up. Oh, I'm sorry, that's a rich spot. Blue would be lean. A lot of these little valleys down here need to be brought up. That's probably the hesitation right at initial takeoff. So what I'm going to do, I'm going to highlight,
I'm going to keep going for a minute.
turn right. Smooth. So all these cells here, we got all kinds of dips, peaks. We're going to smooth all of that out. So I'm going to interpolate on this side here. So that interpolated everything going up. Smooth all those numbers out. Then I'm going to come over to here and I'm going to interpolate it this way. Using this button here, click it, and watch the numbers change. There we go. Now when we go back to the 3D view, you can see where we smooth out all that. We still got that big peak right there. We'll have to make a change there. When we take off around this corner, we'll see if it's got that lean hesitation. AFR right there.
Drives pretty good as far as I know, but when I get on it 2,500 or so up, I get these like little hesitations.
Yep. So where you're talking 2,500, your map is still all kind of wonky. So I'm gonna highlight here down over to capture that weird spot and interpolate it. Okay. Did you ever get Megalog Viewer?
I didn't do that yet.
Okay, alright, so we can't data log yet. See on real time, right where we're at. AFR too, geez. Read that. So we're gonna look at these target AFRs. She needs to be a little bit richer. Out a lot of fuel up top, or was breaking up. So right now it's auto tuning. You can see the cells in the yellow and green is where the amount of time it's spending there. The darker shade of green, the more time it spends in there. The red and blue is it adding and taking away fuel in those cells. You see the different colors there. So I changed some numbers in the AFR table, which it targets. Turn on for 12.5. right, so we're going to verify that the timing on the motor is in sync with the timing that the laptop is showing. So we already got the timing gun hooked up. So we're going to go into the ignition settings, and we're going to go very first menu here. And over here on the top right, it says fixed advance. Right now it's set to use the timing table. So we're going to change this to fixed. And now this line down here, timing for fixed advance, says 10 degrees. So we're going to fire up the motor, and using a timing light, we're going to make sure that the timing on the motor is the fixed 10 degrees. And then we know that they're in sync. So we got the balancer marked for 0, top dead center, using dial back timing gun. I'm going to go ahead and line up the mark on the balancer to the pointer, right there. Where's that? Trying to zoom in here. Where is it? There we go. If I'm blocking it, there you go. Here we go. Lined up. And timing is at 5 degrees. So we are off 5 degrees, retarded. So, nice thing about this is we don't have to touch a distributor, we don't have to do nothing with it. All I'm going to do is go on the laptop where it said 10 degrees, I'm going to change it to 5. And then they'll all be in sync, and then we just change it back to use table, and it's going to use the timing map. Right here where it says 10.0, we will just change that to 5.0. We're going to burn it. Come on, come on, come on, come on. There we go. All right, now we'll go back to the motor. Now verify. There it is. 5 degrees on the gun, 5 degrees on the laptop. Now, stay here, watch what happens. I'm going to switch that map or that table back to use timing advance. Watch what the motor does. Now the timing is set correctly, everything's in sync between the Microsquirt and the motor, so it's all good now. Now we can go ahead and do some more tuning. Now we know that it's been running around 5 degrees retarded compared to what the laptop has been saying, so that's quite a bit, it's a lot of power. Alright, so I'm done with my portion of helping Dan for today. We did quite a bit of street tuning on it. Verified that all the AFRs look good across the board, idle, cruise, under a wide open throttle. The richest it goes is 12.5 to 1, which is perfect. Look at the previous scenes you saw. We verified the engine timing on the motor and that it's synced up with the laptop. I did have to make an adjustment to the trigger wheel offset because even though the computer was connected and controlling the advance, the computer was showing 23 degrees and the engine was only showing 15. So you use the trigger offset to bring those in line. Doing that basically woke this thing up a pretty good amount. That's probably a good, you're talking, it was off 5 degrees base and then it was off another 10. So that's quite a bit of power that it was down just from the timing being retarded. So we got all that straightened out. After we went out and retuned it again, we found the timing table was a little aggressive. We were getting some detonation under the high load areas around 3,000 to 4,000 RPM. So the nice thing about this is we can go in, narrow in on that area, drop the timing back, get rid of the detonation, and then everything's good. We did run into a problem, which is why this Microsquirt tuning system is so valuable. The truck was breaking up, it had a miss. Anytime we hit 3,000 RPM, you could see it in the tachometer start bouncing, you could hear an audible miss in the truck. Dan's already done plug wires, spark plugs, coil, all that stuff. There's no reason it should have an ignition problem. But it turned out, by verifying everything on the laptop, we knew it wasn't lean, it wasn't overly rich, we knew the timing was good. We can see all the other sensors on the motor in real time, and we even know what the inlet temperatures are. Turns out we swapped in an old timing, an old TFI module, and it went away. It cleared right up, no more miss. It pulls clean, well past 4,000 RPM. Just an old Ford TFI module that gave up the ghost finally. So I think my work is done here, and Dan is free to go full send all he wants now. So I think he's good.